Hey everyone, and welcome. Today we're going to dive into the powerful, complex, and honestly pretty controversial world of non-renewable energy. These are the fuels that literally built our modern world, but now they're also presenting us with some of our biggest challenges. So to get a sense of why this is such a huge deal, just look at these numbers. An incredible 85% of all the energy the world uses comes from non-renewable supplies. That is a massive, massive dependence. It powers nearly everything in our lives, from the lights in your room to the factories that make, well, everything. So what does non-renewable actually mean? Well, think about it like this. Nature spent millions and millions of years saving up all this energy, burying ancient life and compressing it. And us? In just a couple of centuries, we're spending that inheritance like there's no tomorrow. It's like we have an energy bank account that we're draining way, way faster than it could ever be refilled. Okay, so here's our roadmap for today. We're going to start with the big three fossil fuels. That's coal, oil, and natural gas. After that, we'll check out the atomic alternative, nuclear power. And then we'll wrap it all up with a quick recap of the key points you'll definitely want to hang on to. First up, let's talk about the original workhorse of the Industrial Revolution, coal. It is by far the most abundant fossil fuel we have on the planet. And to put that into perspective, at the rate we're using it right now, we have enough known coal reserves to last for about another 200 years. It's kind of wild to think that coal is basically just fossilized sunlight from millions of years ago. Here's how it happens. It all starts with plants in these ancient swamps. When they die, they get buried under layers and layers of sediment. Then, over geologic time, we're talking millions of years here, intense heat and pressure squeeze all the water out and really concentrate the carbon. And that's what transforms that old plant stuff into the dense black rock we burn for energy. But here's the thing. Not all coal is created equal. You can think of it like this. The longer it's been cooking under all that pressure, the more energy it packs. So lignite, that's the youngest and softest. Anthracite is the oldest, hardest, and has the most energy. And right in the middle, you've got bituminous, which is the most common type here in the US, and unfortunately, it also tends to have a lot of sulfur in it. Now, all this abundance comes at a pretty serious environmental cost. The mining itself can just wreck habitats. And then, when you burn it, coal releases a ton of pollutants like sulfur dioxide, which is the main cause of acid rain, and of course, huge amounts of carbon dioxide, which is a major greenhouse gas. All right, next up is the fuel that really defines our modern world, oil, sometimes called liquid black gold. If coal powered the Industrial Revolution, well, oil powers our ability to move. It's the lifeblood of pretty much all of our transportation, from the car you drive to the planes in the sky. Getting oil out of the ground is a lot more complicated than you might think. See, the natural pressure down in a reservoir only pushes about a quarter of the oil to the surface. To get more, engineers have to use other methods, like pumping water or steam down there to force the rest out. And each stage gets harder and it gets more expensive. And this brings us right to the core trade-off with oil. On one hand, it's an absolute energy powerhouse, and it burns cleaner than coal. But on the other hand, burning it still releases greenhouse gases. And the risk of an oil spill during transport, well, that can cause just devastating damage to entire ecosystems. Okay, this number, 30, is a really stark reminder of oil's limits. Now, this is based on the reserves we already know about and how fast we're using it. So without major new discoveries, we could use up what we have in as little as 30 years. It just really highlights how finite this resource is, especially when our entire global economy is built on it. Now let's talk about oil's close cousin, which you often find right in the same underground spots, natural gas. It has a reputation for being the cleanest burning member of the whole fossil fuel family. So natural gas is mostly just methane, and its biggest selling point is that it has almost no sulfur. So when it burns, it doesn't create all that sulfur dioxide that causes acid rain like coal does. It's moved around through this huge network of pipelines and is a super common fuel for heating our homes, cooking food, and even for making fertilizer. All right, let's totally shift gears here. We're moving away from fossil fuels, which are all about chemical reactions, burning stuff. Now we're going to talk about something completely different, nuclear power. Instead of burning carbon, nuclear plants create energy by splitting the very core of an atom. The entire technology really just hinges on this one incredibly powerful process called nuclear fission. To put it simply, it's just the splitting of the center, or nucleus, of a heavy atom like uranium. And when that nucleus splits apart, it releases a massive amount of energy, which we can capture as heat. And here's where it gets really interesting. This process creates a chain reaction that keeps itself going. One splitting atom releases neutrons, which then hit other atoms and make them split, and they release more neutrons, and so on and so on. In a power plant, this whole reaction is carefully controlled to create a steady, intense heat. That heat is then used to boil water, create steam, and turn turbines to generate electricity. So this leads us to the huge dilemma of nuclear power. On the pro side, it's pretty compelling. You get incredible amounts of electricity with absolutely zero greenhouse gas emissions. But the cons are just as big. We're talking about the staggering cost to build these plants, the small but very real risk of a major accident, and the problem that we still haven't solved. What do we do with the radioactive waste that stays dangerous for thousands of years? All right, I know that was a lot of information to take in. So let's do a really quick recap of the most essential things you should take away from everything we've talked about today. Okay, here it is in a nutshell. Remember this. Coal is the most plentiful, but also the dirtiest. Oil is the king of transportation fuel, but we're running out and spills are a big risk. Natural gas is the cleanest of the fossil fuels. And finally, nuclear power is emission-free, but it comes with huge safety and waste problems we haven't solved yet. And so all of this leaves us with what is probably one of the biggest questions of our time. And there are no easy answers. Every single one of these non-renewable sources comes with a really complex mix of benefits and very serious costs. The real challenge for all of us is figuring out how we meet the world's growing need for energy while also protecting our planet for the future. It's a huge question worth thinking about. Thanks for sticking with me today.